Here we are in Chapter 8, Section, there's an 8, 3, problem number 11. Excuse me. The mean yield for hard winter wheat in a certain state is 44 bushels per acre. So we have a mean going on. We've got a number for that mean, so that's going to be something we need to deal with. In a pilot program, a modified growing scheme was introduced on 35 independent plots. Looks like a sample size. We have 35 different independent samples. The result was a sample mean yield of 45.4 bushels per acre, with a standard deviation of the sample of 1.6 bushels per acre, and apparent increase in yield. Okay, so we have a base mean. We have a mean from a different sample, or from a sample, and we have standard deviation for that sample. So it's looking to me like we're trying to see if this increase in yield is from something that they changed, or is this likely to have been just from the same process that was there before? Okay, so let's go into this. Our step A, test at the 5% level of significance. Every time we see a level of significance, that's the alpha. So if alpha is going to be 5%, whether the mean yield under the new scheme is greater than 44.8 bushels per acre using the critical value approach. Then we're going to compute the observed significance, then do the same with the p-value approach. Okay, so I have my sheets printed out in terms of the systematic hypothesis testing procedure, critical value approach, and the p-value approach. Like I have mentioned in other example questions, having those printed out and handy, or having that open on another window is handy so you can remember these steps. All right, so for A, let's go through the steps. First thing, number 1 is identify the null and alternative hypotheses. So our null hypothesis, we've kind of been mentioning that, it's this mean that we're going to be at 44.8 bushels per acre. And our alternative hypothesis is that the mu is greater than 44.8 bushels per acre, because we're checking to see is there an apparent increase, so is it going to be greater than. And going to hypothesis testing, it's a level of significance. We already mentioned that alpha equals 5%, 0.05. Often at this point I'll put in alpha over 2 if it's a two-tailed test, but this is just a one-tailed test, so we don't have to worry about that piece of it. All right, so there we have our hypothesis, our null hypothesis, and our alternative hypothesis. Now we go to our second step, which is identify the relevant test statistic and its distribution. And then there's step 3, which is compute the value of that statistic, which I often do together. I just keep right on going. So let's go ahead and determine our test statistic. We have a process where we're looking at the mean, and we have more than 30, our sample size is more than 30. As we mentioned up here, that our sample, our n, is 35. Here is our mu naught. Here's our mu alternative. And here's our sample standard deviation. We do not have the actual standard deviation for the underlying process, so we're going to have to use our z statistic of the sample minus the null over the sample standard deviation divided by the square root of the sample size. So that's going to be our x bar is 45.4 minus our 44.8 divided by our sample standard deviation, which is divided by the square root of the sample size. There we go. Then doing that particular bit of math, that gets us 2.219 is our z value. Alrighty, let's go on to step 4. In step 4, it's construct the rejection region. All right, so we're looking at construction of rejection region. So on our, we got our 0 over, so from a standard normal curve, we're going to look to see, actually, we're only going to worry about the greater than region up here. So I didn't need to draw that other arrow down there. So this is going to be at our alpha level, which is 0.05. So that much probability there that we're for our level of significance. So let me continue that. So our Z of 0.05, that's handy to pull out of the table 12.3, I think, the bottom line of the t-distribution table. And that's going to give us 1.645 for 5% there. And so our rejection region is going to be from that 1.645 all the way out to infinity. So if our z value of our test statistic is greater than that, then we reject the null hypothesis. And since our test statistic does fall into the rejection region, so we're going to reject our null hypothesis. So the data does provide sufficient evidence at the 5% level of significance to conclude that the average yield under the modified growing scheme is higher than 44.8 bushels per acre. Okay, let's do the same thing again, run the test, but this time with the p-value approach. And well, that's in C, right? In B, we're computing the observed significance. So the observed significance of the test, which is the p-value. For calculating that, to do our p-value essentially is what is the probability of having the test statistic. So our z equaling 2.219. So what's the probability of that happening? So that's asking the question, essentially, if we have this at 2.219 for on a standard normal curve, how much probability is sitting out there? So for z at 2.219, we look at the probability of that. And let's see, that's the probability, actually, because of what we're looking at here, we're looking at the probability that z is greater than 2.219, which is 1 minus the probability that z is less than 2.219. So that's going to be 1 minus 0.9868, which is going to be 0.0132. So our probability that there would be something larger than 2.219 is just barely over 1.3%. Okay, C. So our C, this is actually going through and doing the 5 steps of the p-value approach. The first 3 steps are the same as in the C value. Step 4 is compute the p-value, which we just did. So step 4 was p equals 0.0132. Step 5 is comparing our p-value to our alpha value. So our p is less than alpha, so the probability of this event is less than the level of significance that we're looking for our hypothesis test. So because of that, we are going to reject our null hypothesis. So the conclusion there is the probability that this is not from a different distribution is 1.3%, and we were looking to be within 5%, so we reject it. All right, number 11.